some of the plans for the rest of this semester. I think I posted it already somewhere here. Okay. Right, this week and the next week. Oh, this is for the next week, not this week. I didn't plan for this Zoom till when I posted this. So I thought today we'll meet in person on Dobbs Ferry campus, but it didn't work. Mainly because of the weather, inclement weather. Weather is not really terribly bad. Anybody has any snows? None?
I had some snow this morning, but I got a lot of ice everywhere. So I
Oh,
definitely
what city
appreciate.
is it?
I'm in New City, New York. I'm across the.
Oh, New City. Okay.
Yeah,
Yeah, all depends. Yeah, I know. Well, it's better to you then.
yeah.
Okay,
I'm
next week there's no class in person, but I rather meet you for the Zoom. In this Zoom, we're going to wrap up this class, and also I give you some of the review of the final exams. Oh, this is not mid, this is final preparations. Let me see if I can change it. Okay, this is final presentation. Exam schedule. So week after that, which is 2 weeks from today at 7 p.m. I want you to prepare for screen lockdown. You guys already practiced uh, at campus, but at this time, you need to do that at home. Okay, screen lockdown. So we start with the Zoom meeting, and then you can switch over to Blackboard. That's what we are going to do. Anybody has any question about this? The plan for the rest of this semester. So next week and the week after that. Okay, then we move. Move on. We close this. I'd rather close this. Close that. Okay. Give you lecture first. Okay. Regular expression. Regular expression. This is one, we call that RE in many cases, regular expression. You guys need to know that, right? For cybersecurity professionals, regular expression is very, very important. This is not only in the context of Linux operating systems, but in many scripting codings or the representation of some instances, then we need to do, many cases we consider regular expressions. So what is a regular expression? One good catches that I made, this is really what I made. I modified this a little bit. One hook of a bait for many catches of similar fishes. Okay. One hook, many catches. That is the regular expression. Example for that. Consider, for example, I want to find a specific phone number that may be related with, connected to the criminals. So how can I find this number? If I know specific number, then I don't have to worry about. But if I want to find from the big volume of documents, is there any phone number stated? Is there any IP address? Is there any email address? Is there any date, calendar dates, whatever the dates? Is there any human names? Is there any something, right? Without having to read line by line if we want to search. Of course, once a document is electronically available. Okay. This is one of the examples, but there are many other similar phone numbers available in my documents. Then how can I search it? Should I read it? I know one specific number, then I know how I can search, but can I find any number like a phone number from my documents if I have millions of documents available? Okay, then this kind of things is some of the descriptions. Okay, if I know specific, then I can specify like this. If I do not know, then I can say, or if I know, hey, I want to know something, some phone numbers starting with the 917. I don't care the rest of the number, but I do care the first three number in a phone numbers. Is there any such numbers available? Okay. Then this is kind of the expression. So we're going to learn this expression, okay? But right now, I'm giving you some motivations. So what about any phone numbers? Any phone numbers, like 3-digit dash, another 3-digit, and ending with the 4 digits. Can I find out this? Okay. Without having to specify, but I want to see if there are some numbers like this. Of course, there are not necessarily phone numbers, but could be possibly if number formed in this way, right? So by one hook of baits, I want to catch every fish in the same kind. Or I know there's a phone number, but I don't remember. The one that I know, that I remember is a 917 somewhere in my phone numbers. This kind of the witness, very likely when you see some accident and then license plate number, somebody ran away, but you can catch some number from that license plate, right? 3 numbers or 4 characters or whatever, single character or whatever. I do not know where that is, but that specific partial information is accurate. So can I catch up further? That type of things possible, right? So in that case, this kind of expression is needed. So we'll look at those today. So what is a regular expression? Regular expression is a sum of formation of text string patterns. So that regular expression is very effectively used for match, search, manipulations of text. Okay. And programming languages provide some of the models for RE, regular expression. Linux, you don't need to explicitly import the regular expression, but Linux operating systems are already built in. For example, Python, then you have to import RE if you want to use this regular expression in your Python codings. And also, the Linux has a command called the grep, right? So we want to use this grep. So grep, in this particular example, does not describe yet regular expression. Okay. I want to find out from any file, so star.star, from any file, the word mercy. So to express regular expression, then there's special characters. Meta characters can be used in regular expression. This kind of meta characters maybe meaning differently in regular expression, in general, in normal expression. But in this regular expression, then you have to use it carefully. For example, we have a caret and $. This caret, if it is inside the square bracket, that it means outside the square bracket. If we do not use a square bracket, then that is meta characters. If anything inside the square bracket, then we call that this is a not meta character. If it is inside the square bracket. Inside the square bracket, then it means instead of we call meta character, we call that special character. This is also used in regular expression within this square bracket. See here, square bracket and then caret and 0 through 9. Then we have to understand what this square bracket means and what the caret inside the square bracket means. Okay, first of all, if a caret appears without the square bracket, so anything square bracket start with something, it means I want to find out hello, any word, any sentence, any line in that documents starting with hello. Okay, starting with the HELLO, then that is. Therefore, if we say hello, then this line does not start with hello. It starts with S, say, right? So this is not the case of here. If you want to find out, for example, grep caret hello from some documents, then it means any lines starting with hello, that's what I want. For some reason, if we want to use square bracket, then it means except, other than whatever following. So I want to find out other than whatever following. This is square bracket here. This square bracket means any character in X, any character in X. So you can say 0, 1, 2, 3, then the characters, one of those, 0, 1, 2, or 3. But if you say, for example, caret 0, 1, 2, 3, and close square bracket, it means anything other than the following within that square bracket. So if we have a number 4, then that can be matched. any characters A, B, C, D that also matched. So square bracket means we want to consider any single from here. So either 0, either 1, either 2, either 3. 4 of those, my interest when I do square bracket. But if I say it's caret, then no, not one of those. Anything but one of those. Then we can use this. We need to list them, each element. Or if we see, oh, there is any range, like here. Range means, this means range, okay? So 0 through 9. 0 through 9. By expressing this, square bracket, caret, 0, dash, 9, square bracket, it means any but digits. Any but digits. That's what it means. So likely this caret, if we say $, that's the end of the line. So actually, if we say start with the character H, hello, then you need to caret hello. If you say, hey, I want to find out any statements ending with hello, then you need to say hello. And $. Therefore, it understands, oh, it ends with hello. Okay. So $, indicating the end character. So by itself, it positions at the end. The caret, the beginning. So its position itself is in the beginning of that descriptions expression. Okay, dot means this is any single character. If you say dot, any single character, then you can say dot. The backslash, usually we call that escape character, right? Backslash D means single digits. Backslash dot means decimal points. But this kind of things is not available in Raspberry Pi operating systems. But in other regular expressions, general regular expression, you can say a backslash D. For example, in the Python codings, you can use that, but not in the Python. So not for Linux. This is very common. Question star plus. This states about the quantifier, number of occurrences. If you say the question mark, then it occurs 0 or 1 time. Star means it occurs 0 or many times. Plus sign means it occurs 1 or many times. It's a question, star, and plus. This is very common, right? I believe this is yeah, in many subjects that you learned this case. Again, we have a square bracket, parenthesis and curly braces. Square bracket means any character, any single character from there. Parenthesis, this is like a grouping. So all in that X together. This parenthesis with the commands that we learned, right? That's a group of commands. I believe that is on your midterm exam as well. So same concept. Parenthesis, then there's a grouping. Curly braces. So minimum, this is the occurrence. Minimally, it repeats m times, or maximally n times. Some of the repetitions. How many it can repeat? Okay. For example, if we say any character A through Z, if we have a square bracket, any character from A through Z, because this is a square bracket, single character, right? If we say, hey, I want to specify, for example, password. Passwords should be at least 8 characters, at most 12 characters. That is the policy of the password creation. So you can say number 8 minimum and number 12 maximum. It doesn't allow only A through, only small characters, A through Z. You can add more, right? You can put some special characters. You can do many of such as, for example, A through Z. And then maybe dot possible, dot possible sometimes, right? For password, I'm not sure. Some special characters, question mark, %, whatever that you want to allow. And then you can say, from here, one only, right? Either one of this range, or dot, or exclamation mark, or %. That type of things takes place at least 8 times, at most 12 times. You need to specify like this. It's a little bit of a confusion if you do not practice a lot, right? You have to practice a lot. Otherwise, maybe confused. Or at least if you know cheat sheets possible, right? For your final exam, because the final exam is online, so everything is possible, right? You can open up textbooks, but I would rather to not. It's very hard for me to proctor you sincerely if you have two the laptops available, then you can search the internet, but internet search is prohibited. Right. Therefore, not only lockdown, but also camera doesn't help much if you have more than one digital device available. But anyway, we go for that. Okay. So in general, the open book test, but time is limited. I'm not going to allow you to take a longer time finding out something from somewhere. So this is a limited time because of that flexibilities. I want to protect the sincere guys from doing some unexpected behaviors. But anyway, so let's move further. This is a pipe, right? Vertical bar that we looked at already in many cases. This is the escape character. So, for example, within, if you want to include parentheses, then you need to say, without parentheses itself, in this regular expression, treat as a grouping, right? If it is a parenthesis. So if you do not intend to group, but parenthesis literally itself, then you need to do backslash, open parenthesis, and backslash, close parenthesis. Okay, this and that, literally. So escape character that I explained here, special sequence, for example, backslash n means a new line, backslash t means tab. This kind of things, you learned it from anywhere, right? And for example, backslash b, word boundaries. If we do not want to use, for example, email address, jayun@merge.edu, then you want to have something white space. You expect white space before jayun email begins. You do not want to, for example, 123 jayun@merge.edu. You want to split these guys, not really split. You want to identify, hey, this is not what I want. I want, there is some word boundaries, white space before this, the regular expression that I want to catch. As I said, backslash d meaning the digits, any digits. Backslash capital D means non-digits, likely backslash W, backslash capital W, non-word characters, right? So in Raspberry Pi OS or POSIX, use POSIX URI, extended regular expressions to express this zero, rather than saying backslash D that occurs 3 times. So digits, 3 digits, that's what it means. But it does not work in Raspberry Pi OS. Okay, so instead of this, in regular Pi expression, we want to use this. This is a regular expression. This is operating, the Raspberry Pi operating system's regular expression. This type of expression is not only used for Raspberry Pi operating systems, but in general, this is very, very general, okay? If we use this, then this is a limited use. Okay, for example, -d, this is for digit. Some understand this, but not all the cases. If we say square bracket 0-9 square bracket, it means any number between 0 and 9, right? One single number. How many times? 3 times. This kind of expression is very, very in general, not only in regular, the Raspberry Pi, but many others. So better to use this, okay? Better to use this rather than this. And I explained it here more in this formal way so that you can, this kind of a cheat sheet, right? So dot means matches any single character, caret matches the start of a line, $ matches end of a line, and star means matches 0 or more, plus 1 or more, question mark 0 or 1, square bracket matches any one character, square bracket and the caret then matches anything but stated here. This is a little bit confusing, right? This and here. If this caret appears within square bracket, that it means except. Curly braces, some of the repetitions. If we have a single number, then exactly that many repetitions. One number followed by comma within the curly braces, then 0 n or more. Okay, or two numbers with the comma in between, then between n and m repetitions. Parenthesis, then a group. Backslash, escape characters. So we already looked at this, right? Anything, then we have a question mark, then any group of this. This is not only parenthesis. You can use this in square brackets, followed by question, whatever that, right? Then this appears 0 one time, star 0 or more times, 1 or more times. So we are ready to practice. Any questions so far? So this is whole the concept of regular expression. So we know the concept. Now practice. Any question so far? Actually, this is the end of today's class, but now practice. All right. So I want to discard this. I want to leave this here. And then application, VNC viewer. I have here already my Raspberry Pi. Mercy. Open up. Terminal. Do this. And we need to practice. Okay. Direct ls. Okay, I want to do cd IASP 221 directory December the 2nd, CD December 2nd. Okay, so let's practice directory list. I want to make a directory list. How can you see the directory list? By the way, I want to find the one more smaller for my extra explanation. This is my home directory. I have lots of directories, right? How can I list my directory? Then ls -d and then / then I can see only the directories, right? Only blue characters from there. That's what I can get, right? So if you want to do from, I think this is enough. Okay, so I want to make a file of that. Then you need to have a redirection, right? So that I can say dir list.txt. But I want to save this in my IASP 221 directory, DEC to that directory. I want to save it to that directory, this directory here. I want to save it. Right now I have nothing, right? ls, nothing. But I want to save this into this directory so that I say, if you want to do more specifically, then this is okay because right now I am my home, right? So from my home, the directory is IASP221. Below another directory, DEC2, and then file name. So I want to that is this. I want to put everything of this into that documents. So hit enter, then it goes there. So when I come here, then that is there, right? So if I want to see that directory list.txt, then I can see these are the directory list, right? In the directory list, grab anything from here, any characters A through Z from dir list.txt. Then these are the directories. Only something excluded from there is this. IASP221 is not the capital, it doesn't start with the capital A through Z, right? This you can do within this quote and unquote, doesn't matter. It works. Okay. If you want to see, hey, I do not want to anything but A through Z, then you can do the in this case. Anyway, it opens everything, right? So I want to, this is very, if it is matched, then it's start with red color, right? Red color matched from there. So uppercase red matched. Here, when you say anything, I want to match anything but uppercase, the capital characters. So if you see the red, then anything lower characters, right? So black that doesn't match anything red. So if you want to see, I want to see the output only, then only the output, right? It doesn't look good. But anyway, like this. I want to see man graph. See if there is anything further. This is our extended regular expression that I try to use, minus uppercase E. This is a Paul type regular expression. So it interprets patterns as a Paul compatible regular expression. So what is Paul? Paul is so another the scripting language like PHP. Paul not widely used in computer science, but still Paul is very, very useful. You guys understand. We don't really teach Paul, but you can catch some of the concept of Paul. You don't really need to understand all the time the Paul language, but simply see, oh, there is a specific language called the Paul. And this regular, the grep, Linux command allows Paul interpretations. E, that is pattern, F file, I ignore the cases, V forward, W word expression, X line expression. Select only those matches that exactly matches the whole line. So minus X. So we're going to use this minus X. So here, E and lowercase x. Oh, because I have here 221 IASP. I want to capture this IASP, but except that. So let's see if we do this. Okay, grep, and then lower LST. Still, so lower character only. So this is a lower character, right? The number that is included in this particular case. But anyway, yeah, this works and that works. If we allow either that or that appears as many times as it can, and also the vertical bar. This is not pipe, this is OR expression. And then if we say 0 through 9, and then as many as it can. Yeah, in that case, we can get this, right? So this means we do not want to the uppercase. How many times? As many times as you can. Or this vertical bar, or, and then as many times as the number, so that we include the IASP 221 and that, right? That's what it is. So if we do not have this X, see what happens, then everything with that, right? If we say X, only something, I want to display the lines, only that line matches. Then we can get that. Vertical and the pipe, and when you say vertical bar, then sometimes we can see that is the pipelines In general, in Linux command, if you have a vertical bar, then that is a pipe, right? So I explained that in the last of today's lecture notes. Yeah, vertical bar, it can be or pipe. If it is in regular expression, it means or. So I use that, right? Here in this regular expression, I used a vertical bar. This vertical bar is not the pipe that happens in regular Linux expression. We explain that before we get to that. So, okay, IP address. This is IP address. Let's explain here. Backslash and less than sign and backslash greater than sign means anything we need to hit here word boundaries. Sometimes we can use backslash b. Remember that backslash b? I would say here backslash b is meaning the word boundaries, right? But this is not working on this Raspberry Pi. Instead, we use backslash greater than sign and backslash less than sign. When we see IP address, then before and after of that IP address should be a white space. Then we can catch all of those as a IP address. It depends on your need, right? Some documents may continue to without white space, so then you don't need to worry about it. But if we clearly see, hey, this is a IP address with white space before and after, then we need to describe it in this way. So IP address is say this is a group, right? The group. Question mark. This doesn't look good. Okay, let's look at this. This is not, well, let's look at this. So any number, at least three numbers, at least one number, at least three numbers. So for example, 129 dot, 168 dot, 1 dot, some, then that repetition, right? It starts with that number, followed by at least the one number, followed by dot. So another here, backslash dot, therefore, this is not, in regular expression, dot means any character. If you want to escape from that meta character, therefore literally dot, then you need to say backslash dot. Parenthesis, that is the group. Backslash dot means any three numbers followed by dot. And then another three numbers. So which is square bracket 0 through 9, close the square bracket, how many times? At least one number, at most three numbers. So this things, how many times it repeats? So first number here appears, followed by three more numbers. That way it can be IPv4 address, right? So 4 bytes long IP address. That's what we can express. If some documents has file names, so I want to use that file names, right? So some of the file names that we looked at automatically, then IP address and show, then there are lots of IP addresses, right? So can we catch any IP address from there? Then we can see grep and for example 127.0.0.1 from that IP address. Then you can see IPADD show that's a pipeline. So whatever the result here, that will be the target documents of this grep command. Then we can see, hey, there is a 127.1.0.0.1. I found that there. This is that you want to find any specific IP address. What if you want to do, hey, I want to see in general, in a regular expression, any type of IP address that I want to get. Then you need to do, and then 0 through 9, how many times that appears, at least 3, at least 1, and at least 3 times, right? You can do this. Let's do step by step. Then you can get, you don't get any of those. So I want to minus E for that. So anything that you can do here, any 3 numbers, at least 1 and at most 2, 3. So at least 1 here. So at least 1, at least 3. So not only this, but also this is 3, this is 2. So this whole thing can appear here, all right? All red mark here matches this. But if you do more, for example, anything before that happens, I do not want to, I want to have word boundaries before that. Then you need to have a backslash and less than sign, then much simpler. So 6, 1 before we have space so that this matches. But if you see previously, this guy, why this works? Because this is 1, this is 2 digits, this is 3 digits. From here, there's a 1 digit, 2 digits, 3 digits. Everything can be marked. I do not know how many times of a red mark here, but therefore everything is in red mark. Here, only first 3 works, right? So by having this, that you can see the red mark here. So we can do further. By the way, after that, we need to have a dot if we want to see. Then this 655, there's no dot. So this is not qualified when I add backslash dot. So see what happens. There's no dot. Then why it happens? Oh. Oh, here. Wait a minute. Oh, here is our. So everything, this is not possible because there is no dot, and everything's out. Only 127, 0.0.1, because we have 127 dot, 192 dot, 192 dot. So this expression gives me now narrow down, right? A little low. And then I want to see, is there anything that I want to exclude? Not really that I want to exclude, but everything that I want to see here, then together with that, I want to make a group. Okay. And then same thing here, 0 through 9. How many times? At least one time, at most 3 times. And all together. In this way, I have one number in that IP address and another number. Okay, so 2 numbers can be. So one number and 2 number and 1 and 2 and 1 and 2. Why this happens? Because that 1 and 2 and 1 and 2, right? But if I do more, if we start with, for example, backslash dot, then we have this guy red mark everything, but now 127 0 dot 192.168 dot and 192.168 dot. So only those 3 cases. 3 cases are matched here and there, but they are totally different, right? The uppercase doesn't care about the following dot, but in this case, we looked at a dot here, right? So by doing this, if we want to make it more general, then I want to have, for example, this. Once I have this, then I do have this 0, including 0, 196. I want to repeat that 3 times. Remember that it's red highlighted. This, assume 3 digits, followed by dot 3 digit, dot 3 digit, another dot 3 digits. I want to make that 3 more times. Then this first thing that we need to make, I would say, yeah, from there and all the way here, that everything should be 3 more times. Okay. So after these 3 characters, dot followed by dot 3 characters, that is within this parenthesis. How many times that appears? 3 times. Hit enter, therefore perfectly IP address, and IP address, right? If we want to show, for example, hey, is there any IP address clearly? Therefore, before and after, there's no other attached, but white space. Then you need to do backslash and greater than sign. Then we have only one case, right? These 2 that are attached with some other characters, but only these characters, 192.168.1.255. That is only alone, so that we can see here. White space. This does not white space. Or if we say backslash S is a white space. Yeah, only this white space, right? The others not matched. That's what we did for the here, \s meaning any white space character. Find the IP address in the system logs. We have system logs, syslog.1. That is in /var/log. Let's say here, var log. There are lots of log files, right? One of those is syslog1. So if I want to see the size of those files, ls-l, then syslog1. This is quite long, right? So now we know that is syslog.1. First thing that you need to see the file type. So what file is it? Is it something that we can read from our Linux command? Then it says ASCII text, so we can read it. Then we are ready to use it. What that means is that I can get a cat. So that is the file content. From there, I want to grab. So what I want to do here, is there any IP addresses? Then I can do cat var log syslog.1. That's the file. I want to search within this documents if there is any IP addresses. So those are the documents. This is long documents, right? Of course, we can find the IP address manually, but if I want to do by this regular expression, hit enter, then I can see only the regular expressions of those, right? If you want to see only the lines the matched, then you need to put -e here, uppercase E in, then lowercase x, then you can see it only smaller number of those lines. Okay, those are the only matched lines. Every lines, it has their IP addresses. It's quite a lot. A lot of IPs. From into my Raspberry Pi or outgoing, incoming or outgoing. You can investigate further if you want. Okay, directory is in USB. We can find something from the USB. What I want to find the USB here is, let's say I have a USB. Put somewhere here in order to use. Let's see. Where is my recipe? All right, I have a USB here. Okay, so I want to this USB in this Raspberry Pi somewhere, the USB slots, right? So into this port, I want to plug that. And it says remove. So I can say medium inserted, I would say okay. Okay, but I would not read it. So that is available right now. The command that we want to detect is lsblk. Okay, so lsblk, that is a command. If I do unplug, then it'll be gone. So there is no this USB. Okay, there is no, it's not available. This is my SD card. This is a memory stick, USB. So I want to insert it. Okay, and push this aside. And create a memory point. So sudo mkdir -p, and then mnt, that is available in the top level, mount. Let's see first. ls/mnt, then in the mount, oh yeah, already described, I made it, right? I think I made it, -l, then I can see when I made it. I made it November 30th. So already made it. So you need to make this, create a directory. So I already created. Once you create, then you need to mount it. So that is the command here, sudo mount. If you know for sure that is a FAT32 type, the first line. If you do not know for sure, then second line. So I want to go for the second line. Sudo mount command and db sda1. Say if I want to see if there is any SDA1. By the way, SDA1 there, but SDA1, this is the logical device name SD1. So device name SD1 is available, but that SD1 is now empty. I want to mount my USB into that device name. That's what I want to do. So to do that, sudo mount into that device name, the device that physically attached USB, then it goes into. I believe this is so that I can do SD. So forget about this. This mount your file system tab has been modified, but the system daemon still uses the older version, still uses this older version. So still, this is okay. So I can change my directory, cd dev sda1, because this sda1 is already available. Into this, my USB is attached to. So my USB is not part of the device already. I mean, it's connected. I mean, usually connected, but I inserted it, and then this one recognizable. My Linux command can be recognizable. So when I do, this is not a directory, cd. It's the one, should be. cd sda. So SDA, I think, yeah, this is mounted to that. So let's do CD SDA. It's not CD SDA1. Not a directory. It's LSUSB. Oh, LSUSB works. It is somehow, yeah. This is what I want exactly to find out, right? So LSUSB, LSUSB. Here, all others, so four of those are not USB that I want. This is what I want, right? SanDisk. That is, as you see here, there is a SanDisk. If we want to see, for example, LS USB, I want to grab -E, and then start with ID, usually followed by 0 through 9 and A through F. Any of those numbers, how many times? 4 times it appears. So we have 4 times of those appears, right? Any lowercase of a character or a number, combination of those, it appears 4 times, followed by colon, and then followed by number only. It's a number only. In this case, number only, right? But for safety, we can use 0 to 9, A through F, only A through F, right? Because this is a hexacode, 1D, 6B, any number of those. I believe there is a hexacode. So 0 through 9, A through F, that's hexacode. And how many times? 4 of those. See if that is there. So which one is my USB? So this is my USB. Yeah, there's other. I think this is only the USB. But anyway, this is kind of the ID extracted. MAC address. Can you find the MAC address from the similarly? The MAC address can be found from IP link and show that then lots of MAC addresses there, right? So how can we do MAC address? So I want to explain here. MAC address can be, this is a MAC address, right? FFFF, something like this. So like this is something like the hexacode. So 1 byte, this is second byte, this is a third byte, and 4 byte long IPs. I mean, hexacode. The MAC address usually 6 bytes long. So we start with 5 of those, and then followed by 2 of those. So in this case, this is 7 times. But anyway, let's copy and paste this. See what happens. So paste and see. Then I have 1, 2, yeah. So hexa, this is 2 of this, colon, two number colon, 1, 2, 3, 4, 5, or 5 and 6. This is why this is finally true. 1 is okay, I think. Only 1. That's also, oh, then, oh, yeah, one time, but 2 digits. I got that. So we need to have that. This is not, this 5 is these things 5 times, but the last number 2 means 2 digits. The hexacode that we can find it. This is something that we can see in a simple way, IP link show, IP address show. But if you have bigger digital assets to search, then you can still use this more effectively. Suspicious command in shell bash history here, .bash. Everyone has that. Minus L, minus A, then there is a dot bash history here, right? So file dot bash history, then that is a data, so we can see it. So if I see here dot bash history, all of my history of commands appears here. See here, these are the comments that I make, right? So lots of those. So what I want to do here, from the history of the commands, is there any suspicious command? Usually the suspicious command is if we have a rm minus rf, this is very dangerous command, right? Don't try to practice this. This will remove everything about your files. Or is there any sudo password? Somebody came here to do sudo password. Somebody came to my system to change it password. Is there anyone come here the permission mode to 777, which means allowed everything, right? Then we also, that is also one of the suspicious command. So those things can be captured. Okay. I know already time, but I want to finish this. Emails. This is the last ones. This is step-by-step expression. You want to search email. Simply, you want to search this kind of form. Or sometimes you can use, if there is any a little bit of reasonable emails, which means a character before and after this. This is anything, even number, fine. This is the characters. And a little more realistic is there is a dot and LTD, top level domains. So it should be, for example, mercy.com. Then this is more realistic. And then slight tightening so that avoid any between before and after this emails, there is no others. So we want to eliminate. We want to see if there is a white space before and after. Or complex emails, if we have a little bit of the normal ways, academia, for example, MIT.edu, then they do not really do MIT.edu. MIT has lots of the servers. So computer science or media lab, then they have something before MIT.edu. Hopefully we would have that. Then we have cyber.mercy.edu, that type of things. So more gradually, we can consider email formats. Accordingly, we can make an email like this. Okay. So I made the data.txt already. So I made it. So copy prep RE data.txt to IISP 221 December 2. Okay, so IISP 221 December 2. I have a data.txt. So what that document has, it's like this. I made it. My email address is jyoon@mercy.edu, which comes from jyoon@edu at a top level. But so I have here email address. This is a kind of email address, but not really, but more gradually. Some of the emails may be like this, abc@def, or even a@def, or if we have a at bb, or a at bb, or 123 at command, company 123@456, or abc.def.gmail.com, or a.g.c@d.e.com, or more and more that we can consider. So from this kind of documents, so can you get some of the result? So if I copy here and paste, then we have this kind of emails, right? Those are the emails that there. This is a simple email. Another email, like here, we have the @ signs. I think there is no much difference between and that. So here, I think similar, right? So I said here, not much difference. But if we consider top level domain, so that we need to describe here after @ some name followed by dot, and then the top levels. So I can paste it. Then you can simply see what is gone. So this type of things gone, right? This df, that type of things gone, and all others now matched. And even a little more rigorous email address that we can consider. Therefore, in the domain, we have a dot here and another dot. So 2 dots actually needed in general cases. So maybe gmail.com not available. Mercy, we'll see what it does. Yeah, if I say, if we do not allow mit.edu, but cyber.mit.edu, then it comes. So the domain here, after @ sign, 2 dots required. And finally, this is better. So if we include the poll descriptions, like if your Raspberry Pi grabs supports -p, so poll, you can use a poll pattern with -b. -b instead of the white space, you can use -b. So by having this, a little more better, right? They look like all the email addresses. Using this poll minus P options. Rather than minus E, we use minus P. Then we can use this and some others. Date also, there's a patterns, right? YYYY dash MM dash D or MM slash DD slash YYYY. You can describe it as you wish. Okay, this kind of regular expressions will be ask you to practice. That will be on your final, the last homework assignments. Okay, I want you to do that. Valid username. For example, we have usernames here, slash etc password. Then, by the way, cut is, if I want to cut based upon, this is a delimiter, colon. I want to cut the colons. Let me show you this. etc password. This is password files. If you see this contents, each lines, then this is the ID followed by colon followed by X. Usually, as I said, that this is a password, but password is now shadowed, right? And followed by colon and 112. This is a user ID, and this is a group ID, and this is a name, and somewhere there is a home address, and finally shell, right? The Linux shells. So I want to cut based upon colon, and then consider the first field. Minus F1 means the first field from this. So I want to get the first field only. All right. So if I copy this, then from these files, first field only displayed like this, usernames. From that username, I want to grab the user ID that's within this. Start with the alphabets. Remember that caret means start with. If caret is inside the square bracket, then it means except. If it is not within, but in this regular expression, it means it start with lowercase, and then followed by some of the cases, right? So I want to use one of those. So copy and paste here. So among those, if you see here, this is not really user ID, right? This kind of things will be removed, but something looks like user ID will be displayed. These are the user IDs, right? So from the previous, something eliminated was this kind of things. So regular expression is a very, very powerful tool for you to describe, to catch so many things. Catch a large number of fishes by one hook. Okay, so I think this is it for today. All right, any question?
Yeah, Professor, I have a question. How once class is over and after, how will we handle Linux Club?
Oh, I will come with you, right? We'll keep this continually. We want to recruit more students. I'm going to teach the Linux class next semester as well. So that you guys is the first founder group. And then I want to include more. Stay tuned. We already had the, what is that? Some of the SMS or SNS, right? what is the name of that? Right. So we are connected. I will post what we want to do for next. Okay. So it will be, yeah, we need to discuss how we can make this a Linux club continually. And I'm going to meet with IT guys, the Mercy IT guys, next week, next Tuesday. There we're going to discuss how we can visit the Mercy IT data center. So that will be the first thing that we will regather probably in January or February. The first thing that we could do in the next semester. That is a very good question. Yeah, I'm going to make the special announcement. So stay in tune. So the first thing that we need to do in the spring semester is to visit data center. And of course, I'm going to ask you to come, and we'll invite students from next class, Linux class, new students, and we all sit down together. And yeah, I'm going to make it available for some refreshment and pizza, something like that. So everything is possible, but not fixed yet. Any other questions?
That's it. Thank you.
What I want to say, I just forgot. Okay. All right. I think this. Yeah. If I record, then I will make a post. Thank you very much, everyone. Yeah, those who need to join next Zoom next week. I know some of you already got the enough point so that you may not be interested in the joining next Zoom meetings. Still, you guys are welcome. Not only we want to review the final exam, but there's an open issue discussions. So anyone wants to bring any issue, you can come and join us next week, 7 o'clock, Tuesday. Okay. Other than that,